There. Okay, yeah. So I thought, just to make sure everybody's on the same page, I would go over the basics of what this albedo hacking scheme is, and then go into why, general issues on why this is such a terrifying and destabilizing thing. It's a technology which has no real good justification for deployment ever, and it's not something where I think further experimentation is going to tell us a safe way to deploy it, because there are intrinsic problems with it, which I'll go over. So it's a case where the risk of research is that it will create the technology that will make it possible to deploy it at a time when we actually have no idea that there could conceivably be a safe way or a responsible way to deploy this. So, so to give you the general, well, actually, to explain the terminology first, there are a lot of different names for this particular way of messing with the climate that are floating around. The early proponents called it something called it SRM, or solar radiation management. And a lot of us really objected to that term, because it implies that this is a system we understand so well we can manage it like you can manage inventory in a shop, just a routine thing to do. And so then, people have tried to repurpose the acronym and call it maybe solar radiation modification, or I've seen one article where they called it solar radiation mitigation, as if sunlight was a problem that we had too much of. So that's not so great either. So people also call it solar geoengineering. But in the National Academy report, we didn't like the term engineering either, because you do engineering on a system where you understand the outcomes. You also do engineering on a system where you can do a scale model and understand how it behaves and try it out in a safe way before you scale it up. This kind of technology is something where we won't know what it actually does until you deploy it at scale. So there's really no way to answer the essential questions until you actually do it. So it would be engineering in the sense that trying to install a new engine on a 747 that's in flight would be engineering. And it would be a completely different kind of engine running on hydrogen instead of kerosene or jet fuel. So it's just, there are all sorts of problems in the terminology. So in the National Academy report, we called it climate intervention. We call this class of things climate interventions in various flavors, like climate interventions by reducing sunlight and so forth. I like to call it albedo hacking. I guess the neutral term is albedo modification. So I'll just call it albedo hacking or albedo modification. But so albedo refers to the reflectivity. And so it all goes back to the most basic aspects of climate, that going back to Fourier in 1827, we know that the temperature of a planet is determined by the balance between the energy in and the energy out. And the energy in for a planet like Earth is through sunlight. So you have a sunlight that comes in, you have a certain amount that's incident on the atmosphere from the sun, and then a certain amount of that is not absorbed by the Earth system, but is reflected back to space. The portion reflected back is called the albedo. And so a certain amount of energy gets into the Earth. It's on the average about 280 watts for every square meter of the Earth's surface. And then the infrared radiation, just black body radiation, the hotter something is, the more infrared it emits. For things at roughly Earth-like temperatures, you get infrared out. So the only way a planet loses energy is by infrared. So the planet heats up until it radiates enough infrared to balance the incoming thing. And so when you add carbon, so this is the red arrows, the outgoing infrared, which in pre-industrial times is on the average and balanced with the amount of absorbed sunlight. And now what happens when you add carbon dioxide to the atmosphere is it's like adding insulation to your house. It means that the Earth has to get hotter in order to lose the same amount of energy. So if you keep the sunlight the same, but you reduce the amount of infrared going out by putting carbon dioxide in the atmosphere, then the system's out of balance and it's getting more energy than it's losing. So it has to warm up until it comes back into balance. Okay, so now the idea with albedo hacking is that okay, we've reduced the infrared radiation going out by increasing the CO2. That's the smaller size of the squiggly red arrow. But to keep the Earth from warming up, we work on the other part of the energy balance, which is the amount of solar heating. So the idea is to reflect more sunlight back, in particular by injecting particles into the stratosphere where they stick around for at least a year or so, reflect more sunlight back so that you're in balance with a lower amount of carbon dioxide. But it's important to recognize this already is a massive disruption of the climate system, because the way that incoming sunlight acts on the Earth is not identical by any means the same as the way outgoing infrared acts on Earth. And in particular, incoming sunlight reaching the surface is what sustains evaporation to make rainfall. Incoming sunlight has different strengths at the poles versus the equator. Carbon dioxide, not so much so. So to equalize that distortion you're doing to the distribution of energy, the circulation has to do all sorts of stuff. Incoming sunlight does things like affect photosynthesis. That's what plants live off of. And there's a difference between sort of direct sunlight and diffuse sunlight that you get from scattering. So there are all sorts of reasons that when you do this, it's like you clobber the Earth with one sledgehammer and say, okay, we're going to fix the problem by clobbering the Earth with a different sledgehammer and hope nothing breaks. So, we've broken the system, so we'll break it a little bit more. So it's like some people refer to this as, okay, stupidity got us into this problem, so maybe more stupidity will get us out. That's not the framing David Keith likes, but I think that's a true description of the situation. Okay, so the way that the way that stratospheric albedo hacking works is that you inject something up into the atmosphere that makes small particles. So it could be sulfur dioxide, which turns into sulfate aerosols that are small particles that are good at reflecting sunlight. It could be something else. Like even Keith's group has even proposed diamond dust, if you can believe it, which has a better index of refraction than sulfate aerosols. And they're pushing the idea of calcite, calcium carbonate particles instead of sulfur dioxide. But whatever you put into the stratosphere, the idea is you put something in that makes small particles, and small particles per unit mass reflect a lot of sunlight back. And it doesn't actually take a lot of mass of this stuff to reflect back sunlight. And people want to, Keith's group wants to put this in the stratosphere as opposed to doing something down near the ocean surface, because a particle down near the surface gets washed off by rain in about 7 days. The stuff up here stays up for maybe a year or two, as you can tell by how long the cooling from a giant volcanic eruption like Pinatubo lasts, which is on the order of a year and tailing off in the second year. That's why some people call this artificial volcanoes. Volcanoes do this by putting sulfur dioxide in the stratosphere, which turns into sulfate and makes aerosols. So that's the general picture, and I may come back to this later, but if you look at the research at the sort of the rather small research environment in solar geoengineering and albedo hacking, a rather disturbing thing is that the big backers is the tech industry. They're big backers among Silicon Valley moguls, Silicon Valley billionaires, who really like this idea. So it's sort of famous that Freakonomics, the Steve Levitt popular economics textbook, was arguing that this is the obvious cheap way to address the global warming problem. And he was drawing on Nathan Myhrvold, one of the Microsoft billionaires, who in fact has patents in various aspects of injecting stuff into the stratosphere, and sees this as a way of making a lot of money. There's a lot of just sort of techno optimism behind it. And one of the big lobbying groups that's actually gotten legislation introduced into the U.S. House of Representatives to fund geoengineering, though it hasn't passed yet. One of the big lobbying groups is a group called Silver Lining, and their list of donors, it's just like a Silicon Valley who's who. Harvard's group on this, led by David Keith, it's funded by Bill Gates' personal fortune and various other donors. And there's a whole lot of sort of what you might call astroturf governance groups that purport to be just looking at ways to govern geoengineering and being neutral, as they claim, about whether they want to deploy it. But in fact, these groups like the Carnegie Group on Governance, the SRMGI, Solar Radiation Management Governance Initiative, all these things which are funded by private endowments, they really are serving to increase the comfort level with the idea. They're not looking at whether this should just be banned outright. They're trying to make the third world comfortable with the idea that they'll be better off with this. They're just doing a lot of stealth advocacy. So there's a lot of there's just a lot of nastiness going on with the advocacy for this sort of stuff, and it's sort of building momentum, especially in the U.S. right now. And so I find it especially threatening, but especially nasty, that to try to sneak this in under the radar screen, David Keith is trying to do his technology development in Sweden, where for some strange reason he expects it to get less attention than if he were doing it in New Mexico. And I think it's truly nasty that at a time when Sweden is struggling with its own COVID problem and has lots of other problems to deal with, and people are distracted, he's trying to pull a fast one by making this secret deal with Rymdbolaget to conduct this in Kiruna. I don't even know if he's been in Kiruna. He probably imagines that Kiruna is out in the middle of nowhere where nobody ever goes, and would never notice. I have no idea what he was thinking of. But so I'll get to what the ScopeX experiment is in a bit. But now I'll just say I'll unshare this screen and share a different one. Yeah, seriously revolting mess. That's a great term that Kevin Noon was introducing here. Let me find, let's see, I'm looking for my other, let's see, where's my other talk? Put away this one. Oh yeah, here it is. Okay, there's this. Oh, here it is. Yeah, okay. Yeah, I got so many screens open. It took me a while to find it. Okay. 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 This is actually from a talk that I gave at Harvard. That previous slide I showed was from a talk I gave at the Bolin days, I don't know, 5 years ago, to show you how long this stuff has been going on and how long it's been building. This is from a talk I actually gave at David Keith's group at Harvard. So, and I'm not going to go through the whole thing, just a few highlights. And so to introduce you to the most dangerous thing about albedo, stratospheric albedo hacking, I want to introduce you to the problem of what I call termination shock, or the millennial commitment, which is the mismatch between the lifetime of carbon dioxide in the atmosphere and the persistence of the stratospheric particles that are put up to try to cancel out global warming. Okay, so and the basic thing, carbon dioxide has such a long lifetime, it accumulates in the atmosphere, whereas the aerosols don't. So the longer you emit CO2, the warmer it gets and the more CO2 there is. And if you stop emitting CO2, the warming doesn't go away for thousands of years. If you stop putting up sulfur dioxide or particles in the stratosphere, the cooling effect of that goes away in just a year or so. So you've got to keep on doing it. And if you keep on pumping out more CO2, which is likely if people cool the earth by injecting some aerosols, means each year you continue to pump out CO2, you have to ratchet up your geoengineering more and more. So you get into this death spiral, more CO2, more geoengineering. Then eventually there's a war or something and you have to stop. And then you're hit with all that pent up global warming in a matter of 10 years or so. So I'll show you some graphs of that. So that's what we call the termination shock problem, or the millennial commitment problem. And it's truly terrifying. So just to introduce you to the general idea of the sort of irreversibility of CO2 induced climate change, one of the innovations in thinking about carbon dioxide and climate is the notion of cumulative carbon. So cumulative carbon is the net amount of carbon emitted as CO2 in the entire past history of the world. Let's just say the world. Okay, and it's been found that the global mean warming is roughly linearly proportional to the amount of cumulative carbon that you've emitted over all past time. So this is something that only increases, it never goes down. And the amount of warming at the time emissions stop is nearly independent of the emissions trajectory, whether you emitted a lot early and less later, or vice versa. And the amount of warming at the time emissions stop lasts for about 1,000 years without declining. And then it declines only very gradually over the next 10,000 years. And it takes well more than 100,000 years for things to return to pre-industrial states. And 1 trillion tons of carbon is roughly equal to a 50-50 chance of keeping warming under 2 Celsius. So this is from a paper in Nature Climate Change with dozens of authors that I was involved in some years ago. Let's just look at the temperature. So this is the temperature over the past 20,000 years, going back into the depth of the Ice Age, okay? And then these lines are the temperatures you get if you emit various amounts of cumulative carbon. This is about 1 trillion tons, which is what we're on in line to do. And right now, well, actually, we're in line to exceed that if we don't stop. Okay, this is 2,500 gigatons, 3840, and roughly 5,000 gigatons. Okay, that is the top line there. Okay, so in all these scenarios, you emit a certain amount of cumulative carbon, and then you stop. Then you stop after 200 years. You stop by 2200. And so at the point you stop, that's when the temperature has a chance to keep going down, but it does go down very much. So here it says if we do wind up emitting 5,000 gigatons, the temperature goes up by 8 Celsius global mean, which is bigger than the warming coming out of the last ice age, but in a direction and at a speed the Earth has never experienced in billions of years of Earth history. But then what's really alarming is even out to 10,000 AD, that curve hasn't gone down very much. But now if you, these are the left-hand side are temperatures in geoengineering scenarios with termination using a model. But let's look at using a full GCM, and the right-hand panel is from from a simplified energy balance model, which tells the same story. And so what's done here is that you've continued to emit carbon dioxide, giving a certain amount of warming. And then you have then you have cooled the planet by introducing some geoengineering. And now then you stop at various points. So if you stop at this point, this rapid rise is the warming you would see, which would bring you back up to the curve you would have been at. So you're ticking along fine here. You say, oh, it's nice and cool. I can just keep on emitting CO2. Okay, now we discover some adverse consequence, or India is getting in a war with China because India's monsoon is getting clobbered and China wants to stop heat waves. And speaking of that business of non-uniform effects, geoengineering, given that it's more beneficial in some places and more harmful in other places, it sets up the world for a struggle with who gets to decide on the climate. And you can bet that this is just going to be another way for the first world to impose its will and clobber the third world. If it's a matter of Uganda or London, picking what climate is best, you can bet which one is going to win. But then when there's the increase in tensions, international tensions over disputes over what climate you get, you can imagine the scenarios for destabilizing an already unstable world. But anyway, here's the termination shock. You're ticking along, you think it's fine. Something happens, you have to stop. And then you shoot up here really fast. And the longer you go in this death spiral, just happily emitting more CO2, the bigger your termination shock when you finally stop. And the only way to avoid the risk of termination shock is to have an agreement. Is to have an agreement that we're only going to do this after the CO2 emissions rate has gone down to a very low level, and an agreement that we will never do more than, say, a ½ degree worth of geoengineering, where you might have an acceptable termination shock. But the political system, which has not even been able to agree on reasonable things like decarbonization, it's not. We're not living in a world where you can count on the political system to actually stick to an agreement to keep this in the box. I used to say, the kind of world where you can elect, where the most powerful country in the world can elect a president, Trump, who says that it's a good idea to drink bleach to fight COVID. That's not the kind of world you want to unleash geoengineering into. Okay, so I'll just do one other. So that's the millennial commitment problem. If you get into a situation where you need it, you're committing humanity to do something without fail for the next 10,000 years. When have we ever accomplished anything like that? No. And then here's another thing. This is sometimes called moral hazard, but I think moral hazard, which comes from the insurance industry, understates the problem, because we have no way of sharing the risk. There's only one world at risk here. We all have to live here. But the general idea, the way I would phrase what's sometimes called the moral hazard problem, as a species, we tend not to take action or to depart from a comfortable status quo until the problems actually start to become manifest. So what does geoengineering do? What does albedo hacking do? It removes the symptoms of CO2 emission without removing the underlying cause. And so if you don't see the problems, where's the push to actually do the hard work to decarbonize? The most likely thing to do is to do some geoengineering. You bring the temperature down to where the problems seem tolerable, and so you emit more carbon. Then you have to do some more, bring it down again, and before you know it, you're in the situation with a really lethal termination shock waiting for you. And now, David Keith's bunch and various sociologists, economists, have done these sort of questionnaire sociology studies where they argue that moral hazard is an overestimated risk. But my answer to that is, when have sociologists or economists ever been able to predict anything? Or if you look at it this way, when has the tech industry ever been able to predict the effect of disruptive technologies? If you look at how little we anticipated what Facebook was going to do to civil discourse, how can we really have any confidence whatsoever that introducing a disruptive technology like albedo hacking is going to be handled in a manageable way? It's just not possible. Okay, and so the part of this fallacy is part of the fallacy of behind a lot of the rationale to develop geoengineering technology is the Plan B fallacy, which basically says, okay, we don't want to do this, but we don't seem to be making progress on decarbonization and reducing emissions, so we need to develop this just in case. But that's just the worst possible justification for geoengineering. There may be some justification for geoengineering after you've already brought your carbon emissions down to essentially zero, where you might only need just a little bit of geoengineering. But the idea of doing it instead of reducing carbon emissions is absolutely loony, because each year you continue emitting carbon, you need more and more geoengineering, and you incur more risk of termination shock. So one of the standard line, and this is very easy for newspapers to pick up, is that we need to do the research just in case as a kind of a backstop. But this isn't a case where it's a just in case thing. There is no plan B if we don't, there is no workable plan B if we don't manage to bring our emissions down to zero and pretty soon. So I'll stop with the I'll stop with that sort of introductory stuff first, and then I'll just outline ScopeX. And so the only, almost essentially the only physical science experimentation on deployment of geoengineering albedo modification that's being done in David Keith's group at Harvard. He and Harvard, with a lot of backing from the university, which loves to see itself as being in the vanguard, whether it's good or not. David Keith's group has been sort of single-handedly keeping the subject of geoengineering research alive. Okay, now there's a lot of simulation work going on in other places, but Harvard is the only place that is actively trying to develop the technology to do this. Okay, now their line is that they're just developing technology to test out some principles that would be used. But the fact is that because of things we don't understand about clouds, the climate system, we won't know how the climate system or the social-political system will respond to this until you do it at scale. So these small-scale experiments don't even address the most critical questions about what this technology would do. But what they do is they develop deployment technology. Whether it's developing balloon flights or whether it's developing technology for dispersing aerosols. It develops nozzle technology. It develops the technology for actually dispersing calcium carbonate aerosols, things like that. It definitely contributes to the engineering aspects while not contributing anything to the big unanswered and unanswerable questions. And so ScopeX, so there's never been a stratospheric physical experiment done. So ScopeX is an incredibly dangerous line to cross. And once you do it a little bit, that's the thin edge of the wedge. It's crossing the Rubicon. It makes it easier and easier to deploy bigger and bigger experiments. And so although ScopeX itself does not release enough material to have a physical threat to anything, it has a huge socio-political threat in terms of opening the way to other and bigger experiments. It just moves the boundary, and it's really a threat. And so to actually have Sweden be in the vanguard and do the world's first stratospheric deployment of geoengineering technology, even if it's not with a release of substances, with the first balloon flight, that would be a scandalous thing to happen. And to have this happen sort of under the radar without asking for any kinds of approvals or even widespread discussion with stakeholder agencies in Sweden, that would be an even bigger scandal. So what ScopeX actually consists of is a balloon with a Kevlar filament. And the idea is to drop an aerosol squirter descended from the balloon to release aerosols in certain patterns, and then you want to see if you can detect those aerosols in the atmosphere and find them to see what happens and what's their particle size, how dispersed do they get, things of that sort. It's a little bit unclear what the ultimate deployment is for the detection, but one possibility is to try to detect the aerosols from the same balloon where you deployed them. And I think in the longer run, they want to use the balloon for deploying the aerosols, but then run aircraft, instrumented aircraft to try to find the plume and measure its microphysical properties. So, but this is all done in the stratosphere. So it would be done with very high altitude aircraft, and probably monitoring it by balloons would be the easiest way to actually deploy something that could detect the aerosols. So what the Kiruna experiment is all about is to test the balloon technology. And ultimately, this would be followed by actual releases of aerosols. But even if the release of aerosols didn't happen in Sweden, the balloon technology test is what would enable Harvard to do this experiment wherever they can find some country gullible enough to let them do it. And that's why I think, you know, there needs to this needs to be stopped in any way, in any way that it can. And that's all I have to say about that.